In this example, we need to determine if the following integral is convergent or divergent. This is an improper integral because of the infinite interval that it's defined on. So we have to rewrite it this way. We have to take limit as t goes to infinity of the integral from 0 to t of y e to the power negative 3y dy. So I'm going to do this integral in steps. First, I evaluate the integral itself right here with limits to and t, and then I will apply the limit. So I'm going to take a separate piece of paper where I will work on this integral. So here's the integral that I need to evaluate right now. Looks like we'll have to apply integration by parts. So I will use the following substitution. U equals y, and then dv is e to the power negative 3y dy. So that's u, that's dv. And then du is going to be 1 dy, or just dy. And then v, so I need to find antiderivative of e to the power negative 3y. So it's negative 1/3 e to the power negative 3y. If you're not sure where I got negative 1/3, what do? Well, you integrate the right-hand side. As you integrate it, you have just to apply basic substitution rule. It's very short and quick. So if you're not sure how I got that, just apply, again, u sub to the right-hand side. And then you'll get this result. Now, so according to the formula, I have to place u times v. So u times v, those two, as I multiply them, I'll get negative 1/3 y. I'm just putting the coefficient in the front. Negative 1/3 y, and then e to the power negative 3y minus integral from 2 to t. By the way, this first part has to be evaluated at t and 2. So we'll do it all at the very end. And then within that integral, we had u dv here, so then here we have v du. v du, negative 1/3 e to the power negative 3y v, and then du is dy. Just in case, here's the formula I'm using, integration by parts formula. Integral of u dv, that's what we had, equals u v minus integral of v du, right? That's the integration by parts formula. That's u v, and here we have v du. Okay, so let's clean this up a little bit. We can put this constant in the front. So negative 1/3, I'm rewriting this portion. Negative 1/3 y e to the power negative 3y. Now as I put this constant in the front, sign becomes positive, positive 1/3. Integral from 2 to t of e to the power negative 3y dy. And what's left is to, I'm rewriting this portion, is to evaluate this integral. So I have 1/3, that's what I had in front. And now integral of e to the power negative 3y, again, I'm doing quick substitution rule in my head. If you're having a hard time following that part, then apply u sub to this. So it's negative 1/3, and then times e to the power negative 3y. Negative 3y. And now all that has to be evaluated at t and 2. Before I evaluate, I think I'm gonna simplify here. So yeah, I can multiply out numbers. Negative 1/3 y e to the power negative 3y. Now positive times negative, so it becomes negative 1/9 e to the power negative 3y. Evaluated at t and 2. Now Now to evaluate at t and 2, so first we have to plug in t for every y. So it's negative 1/3 t e to the power negative 3t minus 1/9 e to the power negative 3t, right? So that's first, and then minus, and then I am plugging in 2 for every y. Negative 1/3 times 2 times e to the power negative 6 minus 1/9 times e to the power negative 6. Next, I will clean up this expression a little bit, so I will clear the parentheses. Negative 1/3 t e to the power negative 3t minus 1/9 e to the power negative 3t, and now I'm distributing negative, right? So negative times negative is positive, so plus, and then 1/3 times 2 becomes 2/3. 2/3 e to the power negative 6, and then negative times negative plus 1/9 e to the power negative 6. And now what I can notice that, first of all, those two are the constants, right? E is the constant, a constant raised to any power, positive or negative or 0, stays the constant. And I can combine them. So to combine, they have to have same denominator, so I'll multiply the first fraction by 3 on the top and on the bottom. So that's going to be 6. 6 plus 1, 7. Plus 7 e to the power negative 6/9. That's that portion, and I'll bring down the beginning of this expression. 1/9 e to the power negative 3t. Okay, so what did we get? So this result actually is not the final answer yet. Let me remind you where we started. This result is what we got from evaluating the following integral, which is not our original integral. That's the one, remember, our original integral had limit infinity, upper limit infinity, but we replaced it with t, right? So that's what we just found. And the result that we just obtained has to be put back into the following limit. So what we just obtained the result for is this integral. And the last step will be to apply a limit. So let me rewrite. It's going to be limit as t goes to infinity of, and then here I'm writing down the result that I just obtained. Negative 1/3 t e to the power negative 3t minus 1/9 e to the power negative 3t plus 7 e to the power negative 6/9. Okay, so how do we find limit of this? So first of all, I can see that there are 3 terms, like I can view it as the 3 different functions added and subtracted, for which I have to find limits. So it means that I can focus on each function separately. So I can find limit of each and then add, subtract the results. That's one of the laws of limits. So I can rewrite this way. Limit as t goes to infinity. So I'm going to just rewrite each with its own limit. Now there are a couple observations I can make right away. So first of all, I can notice that the lost function is the constant function, right? So that is the constant. And limit of a constant is that same constant. So right away I know the answer for that lost limit. So 7 e to the power negative 6/9. But how about those two? Well, I'll look at each separately. I'll split it into 2 parts. So that's part 1, that's part 2. I'll evaluate each limit separately, and then we'll place back the results. So let's try number 1. So it's limit of negative 1/3 t e to the power negative 3t. Now, according to the laws of limits, the coefficient or constant by which function is multiplied can be placed in the front of the limit. I forgot the limit itself. So negative 1/3 can be placed in the front. Negative 1/3 limit of t e to the power negative 3t as t goes to infinity. Now, how do I evaluate this? It is common to start with plugging in infinity for every variable. So if I place infinity here for t and here, will I know what the answer is going to be? I don't think so, because it's infinity times e to the power -3 times infinity, or like what, negative infinity, I guess. So what is that? To help me out, what I'll do, I will rewrite this power so it becomes positive. So I think looking at the function, if it's possible, in a fraction form, sometimes it's helpful when you're finding limits, and that's definitely I can do here. So I can rewrite it as t over e to the power 3t. And now as I plug in limit into the numerator and denominator, this is what I realize. I realize that if I plug in infinity here for t, well, that goes to infinity. And if I place infinity here in the power, then e raised to infinitely large power is infinity. So the denominator also goes to the infinity. So I'm getting infinity over infinity situation. Well, first of all, this is not an allowed operation with infinities. You cannot divide infinity by infinity. So this operation is not allowed. However, this is one of the conditions when L'Hopital's rule can be used. So according to the L'Hopital's rule, if limit produces this kind of fraction, infinity or over infinity, the other case is 0 over 0. Then to obtain the limit, what you can do, you can take derivative of the numerator and the denominator and find derivative of, and find limit of that. So result will be the same. So limit as t goes to infinity. Let's apply L'Hopital's rule. So what's derivative of t? Derivative of t is 1. And what's derivative of e to the power 3t? It's 3, I'm using chain rule, 3e to the power 3t. So we applied L'Hopital's rule. And now what can we say about limits of this function? Well, as I can see here, as t goes to infinity, the denominator gets infinitely large. It's getting bigger, bigger, and bigger, and it gets infinitely large. So the denominator approaches infinity. And as denominator gets infinitely large and approaches infinity, the overall fraction approaches 0. So the overall fraction approaches 0. So that all goes to 0. In other words, I'll end up with 1/3 times 0. And that is just 0. So limit of this first piece is 0. How about the second piece? Second part 2. There we had limit as t goes to infinity of 1 over 9 e to the power -3t. Same thing, the constant by which function is multiplied can be placed in the front. And I need to find limit of e to the power -3t. But it's also going to be convenient to rewrite it with a positive power. So it's 1 over 9 limit as t goes to infinity of 1 over 3, no, not 3, e to the power 3t. E to the power 3t. And now as I place infinity for t, or if I consider that t is approaching infinity, it means that power of e becomes infinitely large. That means that the denominator becomes infinitely large. And as the denominator grows, the overall fraction gets smaller and smaller and smaller, and it's approaching 0. So it's 1 over 9 times 0. So that approaches 0. So result is 0 right here for this second piece. Well, let's put it together. Let's see what we got. I'm moving back. That's what I had to find the limit of, right? For the first piece we got 0, minus the second piece we also got 0, and then plus the third piece, that was the constant. Limit of the constant is the constant, so 7e to the power -6 over 9. So as we can see here, the result as just 7 times e to the power negative 6 over 9, or you can rewrite it as 7 over 9 e to the power 6, either way. But since we ended up with a constant, so first of all, that means that limit exists, and it's a finite number, and you can always approximate it using calculator. So that means that the original integral is convergent. So when limit exists and it's a finite number, then improper integral is convergent, and we say that it converges to this number. So it converges to this number, and the official answer will be convergent, and it converges to 7 over 9 times e to the power 6. So that's going to be the answer.